Okay, in this video we're going to factor quadratic trinomials when the leading coefficient is not a 1. So in this case we've got a number, in this case 6 if you can see it, and that's not a 1. That's the leading coefficient and it's not a 1. It's something else and we can't factor it out. I've got another example over here where the leading coefficient, the coefficient of the x squared, is an 8, and that's not a 1. So we have to use a slightly different technique. It takes an extra step or two, but it's still not too hard. If it's factorable, this is how you do it. You start by taking this leading coefficient, this thing that's different, and you multiply it by this constant term, negative 15. So 6 times negative 15, that should get you negative 90. Make your little crosshatch thing here. The middle term, the b term, is a negative 1. So what we're looking for are two magic numbers, are two numbers that would multiply to negative 90, and when you add them, you'd get negative 1. It really helps to be able to kind of crank these things out in your head as best you can. It just goes so much faster if you've got a pretty good grasp of your multiplication tables. Otherwise, it's a good idea to just go back and practice some of those multiplication tables and think about, what numbers multiply to this that you could kind of put together. Obviously, you're going to need one positive and one negative number if they're going to multiply to a negative. And that means that their difference really is 1. The numbers actually are negative 10 and 9. So negative 10 times 9 multiply to negative 90. When you add them together, you get negative 1. So these two numbers are what I like to call the magic numbers. They're the key to doing this whole thing. And what you're going to do is this negative 1x, right? We don't usually write the number 1, but I'm doing it just to emphasize there's a negative 1x here. And negative 10 and 9, actually, they make up, if you put them together, a negative 1. So we're going to turn this negative 1 into a negative 10 and a positive 9. And just because it looks like it might work better, I'm going to put the 9, I'm going to group it with a 6x squared, and I'm going to group the negative 10x with the negative 15. And so what we're going to have is we're going to have 6x squared plus 9 minus, that'd be 9x, minus 10x. Notice how this plus 9x and minus 10x, if we put those back together, we just have negative 1x. So it was just a different way of writing the same polynomial. And then I got my minus 15. So all I've done was use my magic numbers to kind of break up negative 1 into two different numbers that basically add back to that negative 1. Now I'm going to do some grouping. I can group the 6x squared plus 9x. I've got a minus in between these terms, so when I group these terms I'm going to change that sign. It's going to be 10x plus, notice this change, plus 15. Okay, so now I've got them grouped, I've got a minus in between. Now all I have to do is factor each grouping, and hopefully I'm going to be left with the exact same amount. It should work out because I used my magic numbers. I can take a 3x out of here, and of course that's going to leave 2x plus 3. Minus, here I can take a 5 out. And that's going to leave, guess what, a 2x plus 3. Excellent. This binomial and this binomial, exactly the same binomial. And so what I got is I'm multiplying two things here. I'm multiplying two things here. And both the things that I'm multiplying have a common factor that I can factor out. And I can factor out that 2x plus 3 and multiply it by what's left, 3x minus 5. And now I have successfully factored 6x squared minus x minus 15 into two binomials, 2x plus 3 and 3x minus 5. Now, it might be hard to understand just what a great thing we've accomplished here and how it will help us in the future. But here we have something that's quadratic, and we've got variables x that are both being squared and linear. We can't combine them and do things with. But now that we've broken it out, we actually have two linear terms. Each one of these looks like an mx plus b type equation that you're very familiar with working with. So what we've done is taken something pretty complex, broken it into two things that you're already very familiar with dealing with. And it just makes life a whole lot simpler as we move forward. This is going to be something you're really going to want to be able to do. Okay, so let's do this other one. We're going to do the same technique. We're going to take the leading coefficient, multiply it times the constant term. 8 times 3 is 24. We're going to use our middle term, 14. That's our add 2 number. And now I need to come up with two numbers that multiply to 24, add to 14. And just there's not a whole lot of numbers that multiply to 24, 1 and 24, 2 and 12, and 2 plus 12. Work perfectly. 2 times 12 is 24, and 2 plus 12 is 14. So here we go. Let's go ahead and break this 14 out into a 2 and a 12, and I'm going to put the 12 with the 8 and the 2 with the 3. Doesn't really matter. I think you could do it either way, but that gives me 8x squared plus 12x plus 2x plus 3. And this works out really nice. The 12x and the 2x, of course, make 14x. And I've got my plus 3, I've got my 8x squared. And now I'm ready to group it up. And this groups up really easy because I got a plus in between. I can group those. Here I can easily factor out a 4x. And that leaves 2x plus 3. Over here I've already got a 2x plus 3. And I can't factor anything out of it. But if you remember the divisible coefficient of 1, so remember that there's really a 1 that I'm multiplying times anything that I've got. Can always be thought of as being multiplied by 1. So now I've got a 4x, a plus 1. Both have a common multiple of 2x plus 3. So I can factor out that 2x plus 3. Leaves me a 4x plus 1. And there you have it. I've successfully factored 8x squared plus 14x plus 3 into 2x plus 3 and 4x plus 1.